So first we'll check uh, one-sided signal. Later on we will go with the two-sided signal. One-sided signal. A Fourier transform to a one-sided signal. One-sided signal. Now, so I have this is time axis, time domain signal. Here I am giving a time domain signal. This is x of t. And if I'm going to plot this, so this is a exponentially decaying function. This is exponentially decaying function. So this equation, I'm giving this as x of t is equals to, I'm going to take an arbitrary variable, some constant a, next e power, as it is a decaying function, so we can take this, we can have as e power minus at, where my t lies between, or where my t is always greater than or equal to 0, where my t is greater than 0. Rest of the cases, the x of t value will be 0. So we know our Fourier transform pair. What is our Fourier transform pair? X of omega, is equals to integral minus infinity to plus infinity x of t e power minus j omega t into dt. This is what our Fourier transform. We have inverse Fourier transform also, as we already derived yesterday. So inverse Fourier transform x of t is equals to 1 divided by 2 pi integral minus infinity to plus infinity x of omega into e power plus j omega t d omega. These are the Fourier transform pair. These equations are termed as Fourier transform pair equations. This can be called as Fourier transform pair. Now, here our intention is to calculate the Fourier transform coefficient for this particular x of t. So what we have to find out? We have to find out x of omega. So if I'm going to substitute this particular equation in this particular equation, I can get as solution. So x of omega is equals to integral minus infinity to plus infinity x of t e power minus j omega t dt. So my x of t exists between 0 to infinity. What about minus infinity to 0? My x of t value is 0. So what I am doing is I am going to restrict the limit here with 0 to infinity. 0 to infinity a into e power minus at into e power minus j omega t into dt. This equation can be written as integral 0 to infinity a into e power minus of a plus j omega to t dt. So a is a constant, so we don't require it is not going to affect anything with the integral. So a will be the constant; it will remain same, and e power minus a plus j omega into t, this will be integrated. I'm going to, it is like a e power minus at. So what I'm going to get? So e power minus at divided by a. So as it is, I can get this as, so e power minus of a plus j omega divided by, sorry, j omega t divided by minus a plus j omega. The limits will be 0 to infinity. If I'm going to substitute these values here, I can get as a into e power minus a plus j omega into, what is this, infinity, divided by minus a plus j omega minus a into e power minus a plus j omega. What is the t value? Into 0 divided by minus of a plus j omega. Now, e power infinity, we are going to get the value as 0. So 0 divided by something, I can get 0. So minus, so here minus, once again minus is there, minus into minus I will get as a plus a into e power 0, it is a value as 1 divided by a plus j omega. This is equals to a divided by a plus j omega. So finally, what I can write, my x of omega is equals to a divided by a plus j omega. Now, here we need to calculate the magnitude of x of omega. The magnitude of x of omega is equals to, I can represent this as mod x of omega is equals to a divided by under root a square plus omega square. This is going to be a magnitude. Okay, now how to plot this particular magnitude? So here we have to change with respect to omega, because there is a magnitude of x of omega. It is already frequency domain. So frequency domain, so always it will be in the, it will be having the frequency omega. Here you will have mod x of omega. So this graph will be like this. This graph will be like this. Okay. So in the examination, if they are going to ask about this particular thing, you need to draw like this. Okay. Now, so this is one-sided. As the question is saying that this is one-sided signal. So if I'm having two-sided signal, how I have to find the Fourier transform of find the Fourier transform of two-sided signal or double-sided signal. Two-sided signal. So once again, I have a signal like this. Now, this is both are exponential signals, but the difference is it is a exponentially increasing function. This is exponentially increasing function, whereas this one is exponentially decreasing function. Decreasing function. So from minus infinity to 0, I will have one sort of equation, and 0 to infinity, I will have one sort of equation. So in common terms, they are going to represent this particular x of t as x of t is equals to a into e power minus a mod t. A mod t. So this sort of signals I can represent as a mod of t. A into e power minus a mod t. Now, I can write this particular equation as a into e power minus at, where my t lies between 0 to infinity. Second case, a into e power plus at, where my t lies between minus infinity to 0. Infinity to 0. Okay. Now, so we already know the Fourier transform equation, f of Fourier transform equation x of omega is equals to integral minus infinity to plus infinity x of t into e power minus j omega t into dt. If I'm going to substitute this particular these particular equations over here, so I can write this particular equations as integral minus infinity to 0 a into e power at into e power minus j omega t into dt plus integral 0 to infinity a into e power minus at into e power minus j omega t dt. From this, so e power at, e power minus a j omega t, these are common. So I can write as, I can write this particular equation as c is equals to, I'm bringing a outside, integral minus infinity to 0 e power minus of, sorry, minus of or plus of, yeah, it is plus, right, sorry. So a minus j omega into t plus integral 0 to infinity e power minus of a plus j omega into t. So here dt is there. So here also dt. Now it's close. I can write this particular equation as a into, so this will be e power a minus j omega into t divided by a minus j omega, a minus j omega over the limits, from the limits minus infinity to 0, minus infinity to 0, plus here also I can write this as e power minus of a plus j omega divided by minus of a plus j omega. So this limit is 0 to infinity. Now this can be written as a. If I am going to substitute the limits, what I can get, e power a minus j omega into 0. So this will be e power 0 divided by a minus j omega minus e power a minus j omega into minus infinity. This will be e power infinity, which is nothing but 0 a minus j omega plus e power, again once again, e power infinity divided by minus of a plus j omega minus e power infinity divided by minus of a minus, sorry, e power 0.
Sir, e power minus infinity, no, sir.
Yeah. J omega. So I can write this equation as These two terms are 0. E power 0, that is 1, divided by a minus j omega, minus into minus plus 1 divided by a plus j omega. So by taking the LCM and if I'm going to do this, I can get as a plus j omega plus a minus j omega divided by a square plus omega square. So j omega plus j omega minus j omega get cancelled, and you can get this equation as a into 2 times of a divided by a square plus omega square. Okay. Now, this can be written as x of omega, my Fourier transformed coefficient, is equals to 2 times of a whole power into a divided by a square plus omega square. Now, the magnitude of x of omega is equals to, you can get the same. Only real part we have. So once again, we are going to get 2a divided by a square plus omega square. So from this, we can plot the magnitude response as, so here it is omega and here it is mod x of omega. So once again, you are going to get the same signal as one-sided signal. The difference is only the magnitude, maximum magnitude value is only the difference. Previously, one-sided, for one-sided signal, we got only A by A. We'll get maximum magnitude or maximum value, you can get A by A. Now it is a two-sided, so maximum magnitude you are going to get, that is 2a by small a. 2a by small a. So like this, we are going to solve the problems on Fourier transform on for signals. So we have some more signals also. What are the standard signals? So standard signals, how we are going to solve, we'll see. So before going to solve standard signals, just we'll have a look on properties of Fourier transform. So almost it is also having a same properties like Fourier series. So we have various properties like Fourier series.
సార్
Yes.
సార్ మీరు గ్రాఫ్ ముందు ఒక ఇది డెరివేషన్ చెప్పారు కదా సార్, ప్రూఫ్ అది ఒక్కసారి చూపియారా సార్?
డెరివేషన్ కాదమ్మా, ఇది ప్రాబ్లమ్స్
కాదు సార్, స్టార్టింగ్ లో ఇది కూడా కాదు సార్. ఒక్క నిమిషం సార్, దీని ముందు సార్
ఏముంది,
ఒకసారి థర్డ్ స్లైడ్ చూపియారా సార్? ఇంకొకటి సార్. ఓకే సార్.
So properties of Fourier transform. So before going to learn about this particular Fourier transform properties or properties of Fourier transform, let's have a look on existence of Fourier series or convergence of existence of Fourier transform. We already discussed yesterday. We already have a look on this particular thing, existence of Fourier transform or convergence of Fourier transform. I discussed, I think, I remember. So the first one we have x of t. First one we have as x of t has must have or should uh, have the finite maxima and minima points within the finite interval. As a second one, x of t uh, should have finite number of discontinuities within any finite interval. And the third one, that is x of t should be integral. Should be absolutely integrable. Integrable. That is, we can write this as integral minus infinity to plus infinity mod x of t dt less than infinity. It's less than infinity. It has to satisfy these three properties or these three conditions. These three conditions also termed as Dirichlet conditions. We already discussed this thing. Once again, I repeat it. Dirichlet conditions. Okay. Now, coming to the properties of Fourier transform. So properties, coming to the properties, first property, it is a linearity. So as we already know what is meant by linearity and how it is going to work. We already derived in the last lecture, last Fourier series concepts. So how this will be? A into x of t plus b into y of t. If I am going to apply Fourier transform to this, I can have a into x of omega plus b into y of omega. If I am going to apply once again inverse Fourier transform, I have to get this particular thing. Once again, I have to get x of t, a into x of t plus b into y of t. Such type of situations or such type of signals are available, then we can call that as a linearity. They are satisfying the linearity property. We're going to call that as a linearity property. You require any proof for this? I think you don't require. If you require, we'll discuss. The next one, the next property that we have is time shifting. As we discussed in a Fourier series, here also we have time shifting. So in the time shifting, x of t minus t naught, if you are going to apply Fourier transform to this, I'm going to apply Fourier transform to this, I can get as e power minus j omega t naught into x of omega. This is what we have. This is time shifting. So previously we wrote as x of k. Now I am writing omega. That is only the difference. That is only the difference. Okay. Now the third property that we have, that is the frequency shifting. The frequency shifting, I can write this particular equation as e power j omega naught into t into x of t. If I am going to apply Fourier transform to this, I can get as x of omega minus omega naught. I can get x of omega minus omega naught. Fourth property, there is time scaling. X of at is equals to, if you are going to apply Fourier transform to this equation, you can get as 1 divided by mod a x of omega by a, x of omega by a. It's the time scaling. It's called time scaling. Next one, we have a property called time reversal. You already know this. Time reversal. What happens? Time reversal means I have to go with x of minus t, and I'm going to get x of minus omega. I'm going to get x of minus omega. This is time reversal. So the sixth property we have, that is duality. Duality. If I'm having x of t, capital X of t, this can be written as 2 pi x of minus omega. 2 pi x of minus omega. Okay. So we have 4 more properties. Those things I will discuss in next class or Monday's class. Okay. I will stop here itself. Not going to continue. There are just only the 5 minutes left. You can have doubt session. So far, any doubts? Srilata or something, anybody? Akshaya, Praveen, everyone, anybody?